little bit of an introduction. I guess this is my third Ideas on Tap talk. Every talk that I've given has been Dale Hopkins pretty much forcing me or pushing me up here to do it. And we were talking earlier this week, and he says to me, you know, you've never actually got up here and thanked me or for pushing you up here and getting you to give these great presentations. And yeah, I know I haven't. So here's the agenda for my talk, but while it's up there, everybody can read. I just want to know, the hardest thing about giving an Ideas on Tap talk is knowing your audience, because I never quite know exactly what kind of a crowd we're going to get. So put your hands up if you're not a Vendastian. I just want to know how many. Yeah, okay, we got a decent number. All right. How many are developers from another company? A few. Okay. Well, I'll see what I can do about tweaking it as we go. Most of Vendastians have already heard everything about Elasticsearch, but anyway, we'll go through a quick review of exactly what Elasticsearch is, talk about some of the new features, and just how Vendasta uses it, and how Vendasta could potentially use it. I gave a long Saskatoon dev talk on Elasticsearch, but this is just kind of more of a Vendasta Ideas on Tap tailored talk, so not quite as much detail. I'm aiming for, I don't know, 10, 15 minutes or something like that. So Elasticsearch. Elasticsearch is a data store that is all about search and analytics. You could do other things with it, but you're probably misusing it. I mean, you could probably try to use it as your primary data storage, but you're not going to get the features out of a more resilient or more redundant database. Although they're making improvements on that all the time. But what Elasticsearch does really well is full text search and analytics. It's fast. It's all about the data storage layer. So like really, that's what I'm talking about when I say that you don't want to use it as your primary data store. You really have an intended usage where you need to do some analytics or some search, and it optimizes the data layer for you. It's built on top of Apache Lucene. It heavily utilizes an inverted index, which I'll talk about, and it's also heavily optimized for this. So you don't really have to try to turn your data store or your Cloud SQL or your any other data storage mechanism into a search optimized data store. You can just use something like this, denormalize your data into it as a secondary database. So here's what a data store index would typically look like. If I have a document, maybe a field that has a sentence in it, maybe it's the quick brown fox. Typically, the data would be stored in a data store like you see on the right here. You would have your doc ID as your key of your index, and the values would be the tokens. And so you can imagine if I wanted to do a full text search for the word brown in this data store, I still have to look at every single row of the index, which is expensive, obviously, because I'm skipping over all these other rows that I don't really care about. The inverted index inverts that relationship. If I want to search for the word brown, I can immediately go to the word brown and find all of the documents that have the word brown in it. That's where the speed is. It's really fast. That's where the speed comes from. I have an example here. We have 39 million reviews in our database, in our Elasticsearch cluster, and it took 225 milliseconds to find 451,000 reviews that contain the word pizza. And I mean, really, like, it's not actually having to iterate over 39 million reviews. It's just having to go straight to the word pizza and look up all the documents. So that's where you really get the advantage of using Elasticsearch for the full text search. So, and it scales. It's distributed by design. It is a cluster-based database by design. You can run it on a single instance, but you're not really gaining any of the benefits of it. You know, as opposed to like a cloud storage or something, a cloud SQL or an SQL database. It's really meant to be a single instance. This is meant to live on multiple different machines, potentially even in multiple different zones, and you can optimize your need. In 2.x, they really try to set up the defaults for how your cluster scales for you. There's not as many knobs that you have to tweak in order to get your performance out of it, which is nice because Elasticsearch has a lot of different ways that you can set it up and optimize for your use case. You can optimize a cluster for writes, you can optimize a cluster for reads, you can do all kinds of stuff. And this is how Netflix This is an example of how Netflix uses the cluster for this particular cluster that they're talking about is just for reading through their logs, doing log analysis of what's going on in their systems, and they index over 3 billion documents per day, more than 5 terabytes. Our cluster's nowhere near this size, so I used their example as a cluster that can scale. They've got 700 to 800 nodes, which is literally a virtual machine for every node. So our cluster looks something like this. We've got about 12 nodes. We've got about 705 million documents, and I showed you about 35 million of those are reviews. So, you know, we're relatively small. We're growing. We still don't have all of our data in Elasticsearch. We've only got the stuff that we want to search over, but we're continuously putting more and more data into it. So 2.0 came out last year, and we were on 1.x, and I mean because it's a breaking change, it really slowed down our migration. We really wanted to be on the newest stuff, but of course we had to think through how we were going to get there. I will get to that in a second, but I'll just go quickly over the features that are in 2.x. Pipeline aggregations I'm going to show off later. Much simpler API. I already mentioned earlier as well that they simplified really all the config. They try to do much more of the defaults for you. Huge increases in performance. I've got in brackets doc values versus field data. Braden really wanted me to talk about it, but I'm not going to. So he knows I go way overboard when I talk about that stuff. Another really interesting thing that we used this week was the profile API. Think about if you come from another like a relational database, you might have to analyze and profile your queries before you do any of your joins to make sure that you're joining the right side of the big data versus the smaller table, and so we used the profile API earlier this week to actually see why some of our queries are slow, and we found that we weren't using caching and all that kind of stuff. So that's a handy feature. It's still experimental, but we used it anyway. And then just this week, 2 days ago, they announced 5.0 is in GA. From 2.x to 5.0, what? So 3 of us, as Braden and Jeremy and I went down to ElasticCon. I think it was in March or April or May or something like that. And they were already talking about 5.0 at the conference. It was their big deal. They were releasing 5.0. The reason that they jumped from 2.x to 5.0 is because they wanted to take all these different community driven plugins and start actually developing those as core plugins, officially or supported plugins. So what they wanted to do is, one of the pains is that these community plugins were on their own release cycles. The Elasticsearch semantic versioning didn't match up with it, and they really wanted to get the installation process for companies to install the entire stack to be much simpler, and to guarantee that if you were on this version with that version, that it was tested by the Elastic official community and that it works. So what they did was they aligned all the versions, and they've moved to a train release. So they make sure that the plugins have been tested with the Elasticsearch core, and the Elasticsearch core is developed by a company called Elastic, and that's where they make all their money, is on supporting Elastic. Elastic's free and open source, but you can pay to get this extra XPack down here, which is, I wrote, it's just basically just a renaming of the plugins, and it really is. But they officially support it, and they packed in some features now that you can only get access to if you pay for it. So the second part of my presentation is how we use it at Vendasta, and I've got a couple of product demos. Some of the features that you'll see out of our usage uses some of the 2.x features. All of them benefit from the performance, and a lot of them don't. And I'll get into the third part where we could kind of expand on our 2.x and 5.0 features. But so first of all, at Vendasta, like when we went from the 1.x cluster to the 2.x, we decided we had an opportunity to host it a little bit differently. We've always been in the cloud, and we've always been running our nodes on top of Docker containers, but we were previously putting those Docker containers on top of virtual machines and having to scale the virtual machines manually, provision a new virtual machine, which is heavy. We may or may not have been using the entire virtual machine's resources, so we wanted to go to Kubernetes. Kubernetes is a Docker-based container scheduler. So basically, you define your program needs these resources, and you abstract away your hardware needs from that. You say, I need this amount of RAM, this amount of CPU, and you can have your Kubernetes cluster have much bigger machines, and thousands of them, and it will try to well, anyway, it'll try to find the best place. It'll try to find the best place to schedule that container to fully utilize your hardware. So I'm going to show off what that looks like just real quickly from our Kubernetes dashboard, which I was hoping to show off the newer dashboard because it's a lot more interesting, but it doesn't seem to be working. So what I'm talking about is we've got a bunch of nodes that maybe they're 32 CPUs, maybe they're 36 gigabytes of RAM, and we might say that we only need 2 CPUs to run the Elasticsearch Data 1 node of its cluster. That means that the Kubernetes might want to put 2 or 3 of our data nodes on a single virtual machine for us, but they handle all the virtual machine provisioning. We only ship our container off and let it run there. So that's really nice for us because we're able to scale up by just saying, give us more, and Kubernetes takes care of that. We no longer have to go and manually provision a new Linux machine. We no longer have to, it's almost as easy as clicking a button. So, and it will become as easy as clicking a button when we get a newer version of Kubernetes. Here's how we migrated. It's just some code that we wrote here that said, okay, we're going to configure this particular index that we're interested in migrating to do a parallel write to both the existing cluster and the new cluster. At the same time, that proxy is also saying, okay, because I'm parallel writing to this existing cluster, continue to do reads from the existing cluster. But as soon as we're ready to migrate, as soon as we know that we've migrated all the data over to the new cluster, the proxy was configured to send all reads from the new cluster, and we simply move on to the next index. Rinse and repeat, and we did that until we migrated all of our indexes over. We may have to do this with the 5.0 release as well, because every major release is a breaking change, and you can't just do a rolling restart. But we'll see. It worked really well. We also threw something that is in alpha up in front of our production cluster, which may or may not have burnt us once or twice. But Google Cloud Endpoints V2 came out, and I'm not going to get into what V1 was like, but I will show you kind of what the features of Cloud Endpoints V2 were. So it's a completely different approach than V1, but basically it's just a proxy that sits in front of your APIs, and it can handle the authentication, the stats, the monitoring, the metrics, even the documentation, which isn't quite ready yet. Everything for you. All you have to do is you adhere to a spec to define what your API is doing, and Cloud Endpoints is able to translate that and understands what your APIs are, so that it can bucket in the stats into different metrics. So I'll show what that looks like. Now, and interestingly enough, because like I said, it was in alpha when we started, and we've been working directly with the engineers at Google. Braden happened to get a token quote right on the Google Cloud homepage for endpoints. So he wanted me to show that, but it's not even a carousel. It's literally the only quote that they were able to get. So, and despite this outstanding quote that it may be a little bit of a hyperbole, but might not even be able to show it. Yeah. Well, there wasn't that much excitement to show anyway, because we don't have the full spec for the Elasticsearch endpoints, so it's kind of rolling up our stats and our metrics into the puts and the posts, and rather than actually into the individual APIs. It's still pretty neat. I wanted to show it off because it's part of our new deployments. So Yeah, so let's get into what are some of our most interesting use cases are. I chose the most interesting ones. I mean, there's lots of different dashboards and screens we could go into, but they're not that interesting. They're just doing aggregations or something. But these ones are really our most powerful use cases. So we have a product called National Brands, and it really is a roll-up of all the different Rep Intel accounts that we have in our system. And Rep Intel is, of course, our reputation management, or I don't know what it's called anymore, but it's basically a product that takes and it's able to go and fetch your listings and your reviews and bring them all into one spot. So Brands really rolls up that information up to a brand level, like a Ford or a Chrysler or any of those Subway or anything like that. So really, I'll get into a more interesting, like, actual live demo in a second, but Brands really used to be a huge headache for us. Working with this amount of data required a quite intensive background processing that ran nightly. It would break often. We went through, I think, 2 or 3 different rewrites of it, trying different technologies and everything. And at the end of the day, your data for your brand was never live. It was always a day, at least at most, I guess, a day stale. But of course, if it broke, it was more than a day stale. So going to Elasticsearch really allowed us to replace that large background processing with something that was fast, cheap, and real time, and it works really good. I'll show it off in a second. We also had to it has lots of aggregations, which I'll get into kind of what an aggregation is in a second. But we also had to we were able to utilize something called the path hierarchy tokenizer to allow us to roll that data up at different levels. And really what that means is that Brands can have a tree of your locations. So you could have a node for all the locations in Canada, and you can have a node for all the locations in Saskatchewan. And the Brands report is able to roll up the average review score or the listing score based on the ability for us to use the path. So I'll get into what that looks like. So here's a brand. It's called Topper's Pizza. And if I wanted to show off the hierarchy, how do I do that? Yeah? Okay. Visibility. We're going to go through it all anyway, right? But there's no hierarchy in here. Whatever. Doesn't matter. So what's going on? I'm going to get into the hierarchy stuff in the social posting anyway, but what's going on is you can see this particular brand is Topper's Pizza, made by Dale Birch, who's trolling me over there. And it's in Ontario, so he's got a bunch of locations. I think we found 6 listings for this. And so we are live rolling up the data for this brand for all of their listings, their review rating, and everything like that. And so I'm able in real time. This is basically just a big pivot table over all the data that we know about for reviews and listings. And so I'll move over to the reviews tab here because it's a lot more interesting. And you can see the average review score over the years for this is what I was talking about, these regions for all the locations that are in Canada or the top level region. But I can also drill down into these other different regions, and as you can see, it's fast. It's able to read and adjust and analyze all of this data for all these for all these reviews quickly. And like I said, it used to take us an entire night to calculate all this stuff. So you're also able to actually see what reviews are participating in this chart and do all kinds of filtering and everything. And Elasticsearch is driving all of this. It's rewritten in Golang. It was mostly Braden that did this work. It's rewritten in Golang, and that's because we have to do some client-side joining of Elasticsearch. Obviously, anything that you put into Elasticsearch because of the inverted index is highly denormalized data, which means that you're copying that data over to a secondary place that is optimized for these reads. And so sometimes we have to actually do client-side joins and nice. Non-disruptive, yeah. So Golang was like Golang was our choice for performance in that nature. So multi-location posting is another feature of our brand report. It allows you to do social posting to these different locations that exist in a brand report. And so going back to my exact same brand here, I can use our social posting tool to write a post to Facebook, Google, and Twitter that would go out to the entire brand if I chose. It's much more the same. It's basically just aggregations, but it still utilizes something slightly different, which is a cardinality aggregation, which is it's able to find the number of social post sites that we're actually going to post to based on our brand. And I'm going to show off what that looks like. So I've got our regions here, and I've got Northern Ontario, Southern Ontario, everything selected. I've got 9 locations that are going to be posted to. And right here, you can already see the aggregation in place, the cardinality aggregation, and we're going to post to 8 Facebook sites, 6 Google Plus sites, and 3 Twitter sites. This is doing a lot more than it even looks like on the hood, because underneath the hood, it's actually checking the tokens that we have stored. And I can even click on this red exclamation mark here, and it says that 5 of these locations are not going to actually successfully post because we need to re-authenticate the Twitter account or the Facebook account. So there's a lot going into this stat being calculated real time and live. And I can even shut off the different locations, and you can see it all updates live, but I can even shut off an entire region, and it immediately updates how many locations we're going to. We can handle, I think, up to 5,000 locations without even worrying about any blip in performance of this. And those stats continue through to after you've posted. You still get a feed of posts, but I guess I'm in the wrong brand. But anyway, I thought I had a bunch of posts to show off, but I guess this is the wrong brand. But anyway, you get the stats here for how many locations that post actually worked for. And the last example I have is the reviews tab in the Repentel product I was talking about. So that looks like we go toppers. And we go into this guy. So our review cloud tag that I'm about to show off is a 2-word cloud tag. And we always had, before we had Elasticsearch, a 2-word cloud tag. And the very first release that we released of our new cloud tag went back to 1, and our partners missed it. They said, we need that 2-word cloud tag back. And the 2-word cloud tag's really just, the customers liked it because it gives them a little bit more insight into what people are saying about their reviews, a little bit more context than just a single word. Like it might say best pizza or worst pizza rather than just pizza. It's one of the only places in all of our products that we really utilize the full text search ability of Elasticsearch, as opposed to more of the real-time analysis side of things. And we also utilize the highlight API, and I'll show you that off in a second here. So if I go to the reviews tab, we will actually see the 2-word cloud tag for this location coming in. And so this is what I was talking about, and when you get a little bit more context, because the biggest cloud tag that appears in this cloud is advice management. And so let's go find out what that means. So clicking on it, I get all the reviews that have advice management. This is the full text search right here. You can free type into it if you want, but you can also directly click on any of the cloud tag. And when I scroll through, I can see the highlight API in use. It actually is highlighting the tags, the 2-word cloud tag that we're using. The reason that the word 2 doesn't show up is that we run this past an analyzer that Elasticsearch has built in called the stop words analyzer. Sorry, tokenizer. That's going to strip out all the common words that we don't really care about in a cloud tag. So advice management gets put together, and we can actually see that this Toppers Pizza location is not quite doing so well, because most of the advice to management is that, managers don't give a crap, pay your employees what they deserve, et cetera, right? So that's exactly why a company like this might want to sign up for Repentel. So, and here's more aggregations in place. Everything on this page is driven by Elasticsearch. We've even got our aggregations over here, which are just basically facets or more insight into how many documents match this advice management search. So the last part's going to be really short. This is a couple of the features that we're not fully utilizing yet that would be kind of interesting to utilize. The first one is the pipeline aggregations that I mentioned from before. And so I prepared a little demo on this. Pipeline aggregations allow you to run further aggregations on top of your documents. So like I said, an aggregation might be these numbers right here for all the reviews that match the advice management. How many are from Facebook? How many are from Glassdoor? How many are from TripAdvisor? Pipeline aggregations will let us run another aggregation on top of that and do another calculation. It's really all about saving you post-processing and letting them attempt to optimize your post calculations. It's great for things like moving averages and calculus and everything like that. The example that I came up with was there's another product that we have called Concierge. And Concierge sits on top of Rep and Tell and pulls in the different types of reviews or listings and creates tasks that that a digital agent might have to complete. So, for example, for the taco joint, a digital agent would respond to this review on behalf of the taco joint. The example that I came up with was I wanted to see for a particular partner of ours, which is actually our partner. We have our own digital agency and they do work on behalf of these businesses. I wanted to see if I run this query here, let's see how many of the different types of tasks that they have completed over the years. So the first aggregation I've got here, it's just looking for a particular partner and it's grouping these tasks by category and saying how many of them are completed. So for a review task or like a respond to review task, for the lifetime of this partner, it took 10 milliseconds to calculate that there was, for the lifetime of the partner, 12,820 review tasks completed by our digital agency. So that's nothing to do with a pipeline aggregation, but we can do better. Second example I have here builds on top of that aggregation. I've got this a sub-aggregation, not a pipeline aggregation yet, but a sub-aggregation called the average time to complete. This is the amount of time between a task is created until the digital agent goes and marks that task as completed, or they carried out the process of reviewing a task or making a social post, responding to a review or making a social post. And so if you run this one, it'll take a little bit longer because it's running a script in here to subtract the completion time from the created time. So it took 1.1 second to analyze 152,000 documents. Still not too bad. But now I can see that and I've got this in days. So the average amount of days that it takes them to complete a mention task is 5. They're really good on social posting. It takes about 6 days to do a review. Visibility takes a long time. That's not their fault. It takes a long time to actually claim a listing on a website. And so that's the power of a sub-aggregation with a script. Still pretty cool, but it's not a pipeline aggregation. Well, what a pipeline aggregation can let us do is I can do another calculation on top of that bucket. So rather than post-processing in my code, having to fetch this aggregation and then just writing my own code to do some calculation, like I'm going to do a calculation for the average time to complete any of these tasks, because Elasticsearch was already out there calculating these average times for me. I can now just tell it, okay, pipe this into another aggregation and calculate that while you're calculating everything else. So if I run this one, I get extra metadata at the top. It still only took 1.1 second. I didn't have to write any extra code, and now I have an average time to complete any task of 23 days. So it's all about saving us the extra work. But if I was a mathematician, there would be some way cooler, like moving average or min-max values or derivative that I could put in here and show some cool graph off, but I couldn't think of any better examples. So that's what pipeline aggregations are all about. I'm almost done because I don't actually have a live demo for the Graph API because it turns out that you need a license and we don't have one. So the Graph API is really cool. It's a visual thing and it lets you explore your relationships in your data. I talked about Elasticsearch being non-relational. It's really all about denormalizing data, but there's still relationships there that the Graph API can find and analyze for you. at Elasticon, they gave us the example of being able to find credit card fraud just by finding the common vendor amongst all the credit card transactions documents that were found to be faulty. And all I really have is a graph of it. So as you can see, what's going on in this visualization is that here's all the attendees that attended the London Elastic Fan something, some kind of a conference or something. And what the Graph API was able to do was find that these 4 attendees also attended the ES London conference or whatever it's called. And so the Graph API is really all about exploring your data, analyzing your data, figuring out, finding those relationships that you maybe didn't even know about. And it's a really neat way to analyze your data. We don't have access to it. I was hoping to show it off, but maybe we'll get access to it sometime and Vendasta can use it. So.